Question number 6. Given 4x square plus 2x plus 6 by x plus 1 whole square into x minus 3. First of all, we should split the given fraction, whole fraction into simple fractions. Then we can integrate. To split the given fraction into simple fractions, two or more fractions, we already learned in 11th standard partial fraction. In that exercise, we have learned many of the problems like this way. So I am splitting into different fractions by using partial fraction. That is equal to, we have three factors in the denominator. So a by x plus 1 whole power 1 and plus b by x plus 1 whole square. This x plus 1 is a repeated factor, so x plus 1 power 1, then x plus 1 power 2 will be taken, and then for the third factor we are applying one more fraction, x minus 3. We can split the given entire fraction into three different fractions according to the given factors in the denominator. Now taking LCM, which implies 4x square plus 2x plus 6 divided by x plus 1 whole square into x plus 3 will be equal to a into. Now take LCM here. The LCM is x plus 1 whole square into x minus 3. So here x plus 1 we have. So x plus 1 into x minus 3 will be multiplied. Multiply these two terms to the numerator of a. Now x plus 1 whole square power 2 and x plus 1 get cancelled. The remaining is a into x plus 1 into x minus 3, and then plus b into x plus 1 whole square appear here. If we multiply these, here we have x minus 3 and plus c into x plus 1 whole square. This is the partial fraction. We have learned many problems in 11th standard in algebra. So for a, x plus 1 and x minus 3 will be multiplied. For b, x minus 3 only multiplied, and then for c, x plus 1 whole square will be multiplied. These are the, now equating this, the denominator get cancelled. 4x square plus 2x plus 6 is equal to a into x plus 1 into x minus 3 plus b into x minus 3 plus c into x plus 1 whole square. Let it be 1. Now we should find the value of a, b, c by use of the equation 1. Here I am going to use the equating quotient method. Now equating quotient of x square, before going to equating method, we should substitute some of the values. When we substitute x is equal to 3 here, both the terms are become 0. So put x is equal to 3. 1 implies, which implies 4 into 9 plus 2 into 3 plus 6 is equal to, substituting 3, this factor becomes 0, the entire value becomes 0. Here this factor becomes 0, the entire value becomes 0. 0 plus c into 3 plus 1, 4 square. Here 36 plus 6 plus 6 is equal to c into 16. Now adding these values, 36, 6, 42, 42 plus 6, 48, 48 equal to 16c, which implies c is equal to 48 by 16 equal to 3, which implies c is equal to 3. Now we found the value of c. Again we are moving to, now c is equal to 3 here. Now substituting on another value for x. X is here we have plus 1. Substituting x is equal to minus 1. This factors containing a and c becomes 0. Now I am choosing x is equal to minus 1. Put x is equal to minus 1 now, which implies when x is equal to minus 1 in 1, 4 into minus 1 square 1 plus 2 into minus 1 plus 6 is equal to a into, the substitute x is equal to minus 1, the factor becomes 0, the entire value becomes 0. A into 0, or directly write 0 plus b into, substituting minus 1 here, minus 1 minus 3 become minus 4 plus c into, the factor becomes 0, so totally 0. So we will get 4 minus 2 plus 6 is equal to minus 4b. Simplifying this, we have 8 equal to 4 plus 6, 10 minus 2, 8, 8 equal to minus 4b, which implies b equal to 8 by minus 4 equal to minus 2. Therefore, b equal to minus 2. Reached value of b, we found value of b equal to minus 2. And then we are moving to find the value of a. Because we found b and c, the only value remains is to find a. To find the value of a, we can substitute for x is equal to 0 and then we can find the value, else otherwise equating the coefficient of the term which involves a. That means here multiplying this, we have x square minus 2x minus 3, and then here simplifying, expanding c into x square plus 2x plus 1. Both the terms contains x square. In this term there is no x square. So just equating coefficient of x square on both sides. Equating coefficient of x square on both sides. Because these are equal, so we can equate the corresponding coefficients. Here 4, here a into x square minus 2x minus 3. Multiply and simplify, we will get this value. Here x square, coefficient of x square is 1. Multiplying a here, ax square. So coefficient of x square, left side we have 4. Right side in this term we have 1a. And then here also here 1x square. So multiplying c inside we have 1c. So equating coefficient of x square on both sides, we will get 4 equal to a plus c. This is very easy method. Just equating the coefficients. Equating coefficient method. Now substituting the value of a, c here, 4 equal to a plus 3, which implies a equal to 4 minus 3. Therefore a equal to 1. We found all the values of a, b and c. Now substituting in this, we will get a splitter fractions, the whole fraction splitter value. Here substituting now a equal to 1. Now substituting the values here, we should show all these work out in your question answer sheet. Now we are moving to the next step here. So integral 4x square plus 2x plus 6 divided by x plus 1 whole square into x minus 3 will be equal to 1 by x plus 1 in plus here minus 2 by x plus 1 whole square, and then for c we have 3 plus 3 by x minus 3. Now integrating this one will be equal to integrating the function appear on the right side. Now substitute minus 2 here, minus 2 by x plus 1 whole square. Now integrate, we can integrate these values. Here there are three formulas, we have only one formula here, that is we can simplify this one again, equal to integral 1 by x plus 1 dx and minus 2 into integral 1 by x plus 1 whole square will be taken as x plus 1 whole power minus 2 dx, and then plus 3 into integral 1 by x minus 3 dx. Now integrating, this is in the form of integral 1 by ax plus b whole power n, ax plus b dx, that is equal to 1 by a log of modulus of ax plus b plus c. And then here x plus a whole power n formula applied. X plus a whole power n. X plus a whole power n means integral x plus a whole power n dx is equal to x plus a whole power n plus 1 divided by n plus 1 plus c. We can take it as ax plus b or x plus a. If we take it as ax plus b whole power n, if it is ax plus b whole power n, the a value is multiplied here. The a means the coefficient of x. If it is other than 1, we should multiply. So these two formulas are applied here. Now substituting the first formula equal to log of modulus of x plus 1 minus 2 into here x plus 1 whole power minus 2 plus 1 minus 1 divided by minus 1 and then plus 3 into log of modulus of x minus 3 plus c. We can simplify this. These two will yield a plus 2. So log of modulus of x plus 1 plus 2 by the power minus 1 and the denominator it is plus 1, x plus 1 minus 1 into minus 2 become plus 2. So x plus 1 whole power minus 1 as 1 by x plus 1 whole power plus 1. Now plus 3 into log of modulus of x minus 3 plus c is the final answer. Question number 7. One more question like the previous one. 3x square minus 2x plus 5 by x minus 1 into x square plus 5 is given. In the previous problem we have all are different factors. Here the power is 2, we cannot split furthermore this factor. So this is a single factor, this is also a single factor but it has power 2. So splitting these type of problems we have learned already in 11th. A by x minus 1. Here we have power 2, so assume two variable for that. That is one is bx, another one is c by x square plus 5. There are types in splitting given fraction partially. We have learned 11th standard. The same method we are splitting here. It has power 1, but the x power 1 is x power is 1, so we are assuming single variable. Here we have x to the power 2, so those type of factors are splitted by bx plus c. Or we can take this one as ax plus b by x square plus 5 plus c by x minus 1. You can split any of the two methods. Now I am choosing this way. Here just taking LCM, 3x square minus 2x plus 5 divided by x minus 1 into x square plus 5 will be equal to a into cross multiply x square plus 5 plus bx into x minus 1 plus c into x minus 1 plus c into x minus 1 divided by x minus 1 into x square plus 5, which implies 3x square minus 2x plus 5 equal to a into x square plus 5 plus bx into x minus 1 plus c into x minus 1. This is very easy. Just cross multiply the terms and then cross multiply the denominator. Now eliminating the denominator, the numerator equal to the numerator. Let it be equation number 1. By the previous problem, the method used in the previous problem, we should calculate the values of a, b, c here also. To calculate a or b or c, now I am substituting x is equal to 1 here. If I substitute x is equal to 1, both the fractions get 0, become 0. That means the value of b and c, these two terms become 0. We can easily calculate the value of a. So put x is equal to 1 now. Put x is equal to 1 in 1. We will get which implies 3 into 1 minus 2 into 1 plus 5 equal to a into substituting x is equal to 1, 3 into 1 minus 2 into 1 plus 5. That is left side LHS. The RHS is a into 1 plus 5. Substituting x is equal to 1, 1 square 1, 1 plus 5. Here 3 minus 2 plus 5 equal to a into 6. Simplifying this, 8 minus 2, 6 is equal to 6a, which implies a equal to 1. Now we have calculated the value of a, and now we are moving to find other values for b and c. Here one x square term. When we multiply x inside, we have one more x square term. Here no x square term. So equating the coefficient of x square on both sides. Equating coefficient of x square on both sides of 1 will have the coefficient of x square on the left side is 3 is equal to 3 equal to coefficient of x square left side 3, right side multiply a, we have a x square, so coefficient is a, and then here multiply bx inside, we have bx square, so coefficient of x square is b. Here no x square coefficient, just equating coefficient of x square on both sides, we have 3 equal to a plus b. We found already the value of a by substituting x is equal to plus 1. We have calculated the value of a is equal to 1 already. Substituting that a in this equation, 3 equal to 1 plus b. Now 3 minus 1 equal to b, which implies b equal to 2. This is an easy method by calculating use of equating coefficient method. This is very easy to calculate. So equating coefficient of x square on both sides, here 3, here a into x square coefficient is a, here bx into x bx square coefficient b. So adding these two coefficients and equating this one, 3 equal to a plus b. Substituting the value already we found a is equal to 1 already found. Substituting in this, b equal to 3 minus 1 is equal to 2. Now we are moving to find the value of c. Now here again going to use the coefficient of equating coefficient method to find c. Now we found b equal to 2, b equal to 2, and then now equating coefficient of or equating constants on both sides. That is very easy. Equating constant on both sides, constant terms on both sides. Okay, now the left side constant is LHS constant is 5. The right side constant is, when we multiply a with 5 we will get 5a. And then here when multiply inside, bx square minus bx term will exist. There is no constant term will exist here. When we multiply bx inside, bx square minus bx only will exist. There is no constant there. Here x square term and x term only will appear. But here when we multiply a, we will get ax square, that is x square term, and 5 into a, that is a constant term. So the constant term is taken here. The left side we have only one constant, that is 5. The third term, when we multiply c inside, we get cx minus c. So that minus c is a constant here. So equating constant on both sides of the equation 1, we will get 5 equal to 5a minus c. Now substituting the value of a here, 5 equal to 5 into a is 1, 5 minus c. Now simplifying this, 5 minus 5 equal to minus c, which implies c is equal to 0. So by finding the value of c, we will get a 0 is the answer for c. Now substituting these three values, c is equal to 0. Now we are moving to further step of substituting a, b, c in the given fraction. Now the splitted value we are getting substitute here. So 3x square minus 2x plus 5 by x minus 1 into x square plus 5 will be equal to a by x minus 1. A is 1, 1 by x minus 1 plus bx plus c. B value is 2, so 2x, and then c value becomes 0. You need not worry, that is 0 plus 0 by x square plus 5. Simplifying this, we will get only 2x by x square plus 5. 2x by x square plus 5. So the fraction is split into two more fractions as 1 by x minus 1 plus 2x by x square plus 1. Now integrating the left side will be equal to integrating the right side because both are equal. Integral dx. Now separate and integrate. That is equal to integral 1 by x minus 1 into dx plus 2x by x square plus 5 into dx integral. Here you should know one more formula. Integral f dash of x by f of x dx. Integral f dash of x by f of x dx will be equal to log of modulus of f of x plus c. It will be introduced in next coming exercises, but here I am introducing. This is calculation by using this formula is very easy. For that I am introducing here. You can here itself substitute those formulas. That is what is given here. The derivative of the denominator appears in the numerator when we can apply log of modulus of f of x, log of modulus of the denominator. Derivative of the denominator appears in the numerator. For that the integral formula is log of modulus of the denominator plus c. Now look at the first fraction, first case. This is integral 1 by ax plus b formula into dx. For that we can apply 1 by a log of modulus of ax plus b plus c. So here 1 by a is 1, so need not apply, or 1 by 1 means 1 log of modulus of x minus 1. Now we are moving to the next case. Here look at the denominator x square plus 2. What is the derivative of x square plus 2? d by dx of x square plus 2 x square plus 5, sorry, x square plus 5, derivative of x square plus 5 is equal to 2x plus 0 equal to 2x. So that is in the numerator. The derivative of the numerator appears in the derivative of the denominator is appears in the numerator. We can go these type of formulas. Integral f of x, numerator f dash of x dx means log of modulus of f of x. So we can apply here 2x by x square plus 5 will be equal to, this is the x square plus, this is x square plus 5, its derivative is on the numerator. We can go by this formula, log of modulus of f of x means x square plus 5 plus c. By use of this formula, we are calculating the second fraction's answer. So the integral value of 3x square minus 2x plus 5 by x minus 1 into x square plus 5 will be equal to log of x minus 1 modulus of x minus 1 into log of x square plus 5 plus c. If we need, we can multiply this because they are by logarithm formula, log of a plus log of b equal to log of ab. By use of it, we can multiply this log of x minus 1 into x square plus 5 plus c. Now multiplying these values, we will get log of modulus of x cube, which is equal to log of modulus of x cube, then minus x square, x cube minus x square plus 5x, x cube minus x square plus 5x, then minus 5 plus c will be the answer. Now multiplying these two, will get x minus 1 into x square plus 5 equal to x cube minus x square plus 5x minus 5 plus c is equal to 0. Once I repeating the same, after finding the value of a, b, c by method of using splitting into partial fraction, we will get the values of a, b, c as 1, 2 and 0. Substituting all those values in the splitted value, a become 1, b become 2, c become 0. We will get these type of fractions. Now the whole fraction splitted into two different fractions. Now integrating, we will get this one is in the form of 1 by ax plus b. So applying log of ax plus b formula, plus here the denominator of the derivative of the denominator appears in the numerator. We can go by the formula log of modulus of f of x plus c. So x square plus 5's derivative is 2x. So denominator derivative appear in the numerator. We can go by the formula log of modulus of f of x plus c. So substituting this log of the denominator x square plus 5 plus c. when this is in the form of log a plus log b. We have logarithm formula log a plus log b will be equal to log of ab. So log a plus log b equal to log of ab plus c. Now multiplying these two factors will get x cube minus x square plus 5x minus 5 plus c will be the answer. Question number 8, that is the last problem in the exercise, second exercise, exercise 2.2. Given f dash of x is equal to 1 by x and f of 1 equal to pi by 4, find the value of f of x. Already we learned one formula in the first exercise. F of x is equal to integral f dash of x into dx. Now, substituting f dash of x here, f of x is equal to integral 1 by x dx. Now integrate this function. So f of x is equal to integral 1 by x is log x. Integral 1 by x dx is equal to log x plus c. Log of modulus x plus c or log x plus c. That is log of modulus x plus c, constant of integration. Given 1 for information, one more, f of 1 equal to pi by 4. When x is equal to 1, the function yields value pi by 4. Substituting x is equal to 1 here, put x is equal to 1. F of 1 equal to log of modulus 1 plus c. So f of 1 means the value is pi by 4. So substituting here, pi by 4 equal to, we know that log 1 value becomes 0, log 1 value is 0 plus c, which implies c is equal to pi by 4. Now substitute the value of c equal to pi by 4 in equation 1. This is the equation, the integrated value is taken as equation 1. Substituting in 1, we will get f of x is equal to 1 implies, substituting in 1 implies f of x is equal to log of modulus of x plus pi by 4. The value c is pi by 4. This is very easy to calculate because 1 by x, f dash of x is 1 by x given. Now substituting in f dash of x, that is 1 by x dx. Integrating, we will get log of modulus x plus c. Given another information, f of 1 equal to pi by 4. When x is equal to 1, f of 1 is pi by 4. So substituting x is equal to 1 in this first, f of 1 equal to log of modulus 1 plus c. Log of modulus 1 or log of 1 becomes 0. Then remaining is plus c. Here f of 1. For f of 1, they have given pi by 4, substituting in it pi by 4 equal to 0 plus c, which implies c is equal to pi by 4. Substituting c is equal to pi by 4, the integrated function will get f of x is equal to log of modulus x plus c. That is c equal to pi by 4. Substituting here log of modulus x plus pi by 4. This is the last problem. We have completed 8 problems in the second exercise, and we have similar type of problems in examples. They are very easy to calculate. In those cases, we should apply many of the problems based on partial fractions. So before get through the examples, once you go through our 11th material in the exercise algebra first exercise and thorough the concept of partial fraction once again, and then get into the exercise, because I have worked examples clearly. If exercise clearly, if you go to examples before entering it, we have some of the types also in partial fraction. You learn those concept thoroughly, then go to the examples and make a note of it. We have introduced one more formula today, that is integral f dash of x divided by f of x in dx equal to log of modulus f of x plus c. That is very important. And the forthcoming exercises we can utilize all these formulas and it will be used in the next coming exercises. So we should thorough all the formulas, and I am introducing 2 more formulas, 3 more formulas here. That is very useful for our next exercise. They are, first one, integral e power x. What is the derivative of e power x? D by dx of e power x is equal to e power x. So the integral value of e power x is again e power x. So integral e power x dx is equal to integral e power x dx is equal to e power x plus c. And then second formula, this is 1, and then second formula integral e power ax plus b into dx. What is the derivative of e power ax plus b? D by dx of e power ax plus b will be equal to e power ax plus b into a. Now the a is divided here, so 1 by a e power ax plus b plus c, or e power ax plus b by a plus c we can apply. So third formula is, these are all useful for the next exercise. Integral a power x dx is equal to a power x by log a plus c. What is the derivative of a power x? D by dx of a power x is equal to a power x log a. That is the derivative. Now the constants are divided. The constants are divide the original functions. So here we have a into e power ax plus b. The a divides when integration. Then log a constant divides when integration. So a power x by log a. If we get know thorough about the differential formulas, you can usually convert the integral formulas. So these are the basic ways to convert derivative function to original function. By using those ideas, you can get familiar with the formulas. So e power x is e power x, e power ax plus b means 1 by a e power ax plus b plus c, a power x dx is equal to a power x log a plus c. And then we have another formula, that is a power mx, a power mx plus n dx is equal to a power mx plus n divided by m log a plus c. A power mx plus n divided by m log a plus c. I have given 4 formulas here. These 4 formulas will be utilized in the next exercise, exercise 2.3. So get thorough these formulas with the previous formulas. They will be also used. Now first formula e power x dx, e power x plus c. The second one e power ax plus b dx is equal to 1 by a e power ax plus b plus c. Then a power x dx is equal to a power x log a plus c. And then a power mx plus n dx is equal to a power mx plus n divided by m log a plus c. And these are the respective differential formulas. Now I have written the integral and the differential formulas consecutively here. So thorough these formulas, we'll see the next session. Thank you.